So the first one is a very interesting one. It will be presented by Hristo Tanev, who is a project officer and researcher at the Joint Research Center of the European Commission. So his interests are basically in the computational linguistics, but also natural language processing, and it includes technologies and resources. More specifically, he works on event extraction. This is a very modern and very important line of research these days because it's related to false news and um, maybe forensic linguistics and so on. Also, text classification, question answering, social media mining, lexical learning, and everything is put in a multilingual context. So, what to say about more about Hristo? I have known him for a long time. I would mention that he graduated from the University of Plovdiv, but then he worked in ITC in Trento, Italy. And currently he works in ISPRA, Italy, in the Joint Research Center of the European Commission. Another important thing is that he's one of the founders of the Special Interest Group of Slavic Language Processing at Association of Computational Linguistics. And here I would like to say that we had some work together a long time ago about question answering for Bulgarian. And he, together with a colleague of ours, they developed a system that was called Bulka. Bulka means not only Bulgarian question answering, but also in Bulgarian it means bright. So it's very nice one. And I hope that at some point we can do more about it, right? Hristo, okay. So the floor is yours and please enjoy his course.
Thank you. Thank you for this. Thank you for this very nice presentation. I have listened. As Patty says, I'm working for the European Commission. My primary area of research is socio-political event extraction. I've been teaching assistant in the Plovdiv, in the Plovdiv University, and my recent work was concentrated entirely on working for the European Commission and for the Joint Research Center, and especially in the area of social-political event extraction. So basically, we have built a system for extracting social-political events, news about armed conflicts, about protests, about various types of social-political happenings in the world. And the system was developed, it was multilingual, it works in 8 languages, and it has been used in the African Union, then it has been used for in various intelligence services, even across European countries. And currently it is in use in the European Commission in some directorates, and this event extraction system was the reason that I wanted to share with you a little bit of my experience in event extraction. So this was that our online audiences looks at the slides, because they should be shared. That's why I think this interruption. So I wanted to start with a brief overview of the field. What is event extraction and why one should be interested in it? So basically, in order to make you, the purpose of this tutorial is to make you aware of the most important aspects of the event extraction in the socio-political domain, to give overview of the event extraction technology, to provide information about the event extraction data flow, to look into the algorithms and models used in an event extraction system, and to present some real-world event extraction systems for the socio-political domain. Then I'd like to present three sources of social political events data for training event detection models and systems. First, what is an event? The American philosopher Donald Davidson says that events are special temporal things, so concrete particulars with a location and in space and time. He says this in his work on the logical structure of sentences and actions. It's called The Logical Form of Action Sentences in 1967. And later work on events and their linguistic representation is done by Leonard Talmy in his work towards cognitive semantics. He also explores the linguistic aspects of events. What is important about events? They're central for the news. The news streams are based on reflecting events. So event extraction technology is the most important technology in information extraction if you want to process the news, because event extraction detects events and each news reflects an event. The news do not reflect facts about people, they do not reflect scientific facts, the news reflect events. So the events, under them, there are named entities, there is time, there locations, there are sentiments. So all these information extraction technologies somehow are under the event extraction. The event extraction is the most important technology if you want to process news streams. And so events are central for the journalism and the media, and in fact news articles and news streams are reporting on events. Social media posts which reflect news and also reflect events of various importance and nature. So event extraction is important because the news nowadays are extremely large as volume, extremely large as a variety of content. So everyone who wants to process the news should have an idea of what the event extraction technology is, because this technology is about processing news. So event extraction is an NLP task which was born out of the need of political business organizations to monitor news and social media, as I said, and the purpose of event extraction is to extract highly focused information about specific type of events. And they're described in the news articles, these events in the social media communications. The events are reflected in Facebook, in Twitter, in LinkedIn even, also on Instagram, Telegram. Recently we have collected news from Telegram about the Russian-Ukrainian war. All those social media sources are additional source of news together with the mainstream news. So what is event extraction? Formally, event extraction answers to the 5 why, 1H question: who, when, where, what, why, and how. So this news, at least 11 Palestinians have been killed by the Israeli forces in the north of the occupied West Bank. Palestinian health officials said 6 people died in drone strike, 9 clashes in Jenin, and 5 were reported killed in airstrikes in Al Farar, a refugee camp in Jordan Valley. Israel security forces say it is carrying out a counter-terrorism operation. So who's doing that? This is Israeli forces. They started the action, they did the event. The Israeli forces initiated, they triggered the event. It happened on 28th of August 2024, where there are 2 occasions where the Israeli forces hit Palestinians near Jenin and in the Jordan Valley. And what happened? The outcome is 11 Palestinians are killed. There is no further specification how this happened. They used airstrikes or they killed them by light weapons. That's why we said, what is 11 Palestinians killed? Otherwise, this could also be about the way this happened. Actually, the way it happens is in the how question: drone strike, airstrike, and armed clashes. So this is the way. So the what is the outcome of the action. So it is 11 Palestinians killed. Of course, how is connected to what? Because you cannot just say what happened without saying how it happened. But if we want to go to bring our analysis to the end, we can say that what is irreversible skills and how is that the drone strike has dynamic flashes. And why is the reason? The reasons are deep, but Israeli says that in inverted commas counter-terrorism operation because the journalists do not agree completely with the Israeli statement. He just cites them as a counter-terrorism operation, and that's the reason which is mentioned. In reality, what is not there. So you have the idea. Basically, these slides already gave the idea what is event extraction. Research what happened, how many people are killed, who is killed, who triggered the event that's the actor or the perpetrator, how it was done, with what weapons and what means, what tools, and why the motivation, which is more difficult to get to capture from the text, of course. So the brief history of event extraction. Brief history, this reminds me of Stephen Hawking's brief history of time. This is brief history of event extraction. It is 35 years already, this technology, because message understanding conferences were initiated in 1987 and they were financed by the DAFCO, by the Defense Advanced Research Project Agency, which already means that the military and the security people are the first who are interested and the first who introduced this technology. So this technology is primarily client at the security people and the politicians. And the inception of this technology it was in the context of the military. And the DARPA did this competition. The first competition was about open event extraction, which means that there is no fixed template. So the systems were supposed to extract as much as possible participants, names, interactions, types of events, event triggers. But from 1999, they introduced the so-called event scenario template, and this event scenario template says exactly that the event should be, the system should extract the event type, the event victims, the event perpetrators, the event location, and possibly other information like weapons used and maybe also the motivation. So this is the so-called closed event extraction. We have a well-defined event template, and the system must fill this template within the specific slots. So we have a predefined slots. This is closed event extraction, closed domain event extraction. But MUC conference introduced the competition name entity recognition and name entity reference, and they continued until 1997. And then they were followed by the ACE, by the Automatic Contact Extraction, which is a research program for developing advanced information extraction technologies, including event extraction, and it was organized by the NIST, the National Institute of Standards of the United States, and continued until 2008, succeeding MUC, and then it was followed by the Text Analysis Conference. The ACE provides a notated event corpus distributed by the European Language Research Association. So if you want to have access to their event corpus, you must be a member of the ELRA or pay more than 1,000 euro to get this corpus, or you should know someone who has this corpus and ask him how to give it to you for research purposes. Of course, it's okay. Or doing more is not okay. You should buy it. And the text analysis conference stopped the development of the event extraction technology, and then it continued into question answering, sentiment analysis, and other technologies, the so-called TAC tag. And then in 2019, a group of people from the Istanbul University, and I joined to them later, they decided to organize a workshop on challenges in applications in automatic extraction of social political events from text case. So this workshop is the workshop for event extraction, and we're trying to organize this every year, paired with the most prestigious conferences like ACL, like MNLP, RANLP, And if you're interested in event extraction, you should come to our workshop and also should participate in the shared tasks. And we have shared tasks from event extraction, geolocation, and the next year we don't know where we will be able to be at ACL, but we don't know. So we feature various shared tasks on geolocation, protests and battles, shared tasks on detecting social political events, on pre-level document sentences in token level. We have shared tasks on hate speech detection related to events. And next edition will be in 2025 if the workshop is successful to be accepted. I want to say some more about it because this workshop is really the only place now focused on event extraction. The link to the last edition is this one. It is the Istanbul University, and we have a Higgs channel, and we provide corpus from data for event extraction. So this corpus is available in general for the people who participate in the shared tasks. But if you write to me, I will try to give you this corpus, since it is good corpus with various social political events, battles, protests, and unrests, and collected mostly from China and India. So it is geographically specific. What is the template of the social political event extraction? Usually, event description can be put in the following template. There is event trigger, for example, fighting for pay. There is the type, protests with police violence, talking about this example. The time is 15 November, location is Bangladesh, actors are garment workers, they started the protest, and the victims are not mentioned. The motivation is pay, and exploited instruments are also not mentioned, but in general they're here working with weapons, cocktail. And also it's important impact on the population, the infrastructure, and the economy, and they can be shown and formalized with different slots. Like, for example, there will be people who are refugees, internally displaced refugees, for example, destroyed buildings, destroyed homes, financial losses, closed roads, interrupted services inside the cities. So those things can be formalized as slots in the event template. Certainly, the event template is decided by your system, by the system which you're building. So it is not a predefined. There is no one template for all the systems, and it is specific for each system. So continuing about the event template, it can be each event can have its own event template, pretty much like in object-oriented programming. Each object class has its own fields. And for example, a kidnapping event has its own kidnapping template. And apart from type and location and perpetrators, then we have the kidnapped people and then the dead and injured people during the kidnapping. But on the other hand, if we talk about battle, then you will have two sides, attacker and attacked. So two actors, and one is the active one, the other is the passive one. And the number of dead and injured for a battle, for example, is more important. And for the kidnapping, for example, security-related event, it is more important the identities of the kidnapping of the kidnappers and the identities of the people who died, because they're less in number. So usually the event extraction systems, the social political event extraction systems, they're covering specific types of events. So why certain events are being detected by the event extraction system, why others not? Usually it is defined by the impact which the event has on the society, and if the event is important for the people who are writing the news, if it is important, if the event has certain importance for the government and for the big mass of people, for the society. So users and developers of state-of-the-art event extraction system are concerned nearly exclusively with two specific group of events. these two group of events are crisis events and business events. So the crisis events are social political events and also disasters, um, disease outbreaks, and also incidents with large scale incidents, man-made incidents. And on the other hand, the business events, they do not have direct impact on the society, like for example, the change of CEO of a company, but they're important because the company directly influences on the economy, the business influence on the economy, and although these business events do not have direct impact on the society, in principle, they're relevant for the people who do business and companies who do business intelligence. And in the long term, the business event can also have impacts on the society, on the economy of a country. So the crisis events are social political events are subtype of the crisis events. So I'll talk more about them. So there are two types: security-related events and like armed conflicts, protests, and crimes. Big crimes are social political. Small crimes are just crisis events. And then we have also disasters, humanitarian crises, disease outbreaks, as well as financial economical crisis. So these are the important type of crisis events. So business events are usually company mergers, change of the stock price, there's new CEO appointed, etc. Some event extraction system and databases are concerned with diplomatic events also, meetings, summits, treaties, which are considered related to the security. They are social political events which are not crisis events. So social political and crisis events have an intersection point in the armed conflict, in protests, but social political events can also include political events like diplomatic events, and the crisis events can include events which are not social political but have impact on the society, like the massive disasters, for example. So some event extraction system basically they detect exclusively crisis events, and so they are oriented towards disasters and battles and armed conflicts, and some are concerned exclusively with health disasters, with disease outbreaks, for example. There is a system created in New York University pools, which is detecting disease outbreaks. And we in the Joint Extraction Center also have a medical event extraction, part of the medical information system, which detects disease outbreaks. This system is active, and if someone is interested in health-related event extraction, he can use our medical event extraction system. Certain event types reported in news remain mostly out of the focus of the event extraction system, and these are sport competitions, personal events like weddings, social events, press conferences, and cultural happenings. This type of events are usually not considered important for the society, so the politicians and the people from the school, they do not invest in monitoring this type of news, they do not invest in monitoring social events, but they invest in monitoring the protests and armed conflicts. So these are the events which are being monitored. So the criterion of detect or not detect is defined by the immediate impact of the event on the society, and typically crisis event detection systems are capturing news fragments reporting some damage on people, such as death, injury, etc. Crisis events may only indirectly affect the people by destroying buildings, infrastructure. Business events detection systems, on the other hand, are concerned with business events and benefit mostly business organizations. So, social political event, what is it? So, a social political event is this event type, it encompasses military interventions, civilian unrest, protests, strike, riots, terrorism, insurgency, political meetings and summits, international treaties, elections, lack of food and water, refugee influx, massive destruction of crops, infrastructure, famine, drug wars, and financial crisis. So this is what the literature says about social political events. And automatic construction of databases for political analysis and early warning is one of the most recent trends in the socio-political field, in the field of political analysis. There are more than one, actually, probably 10 big projects for constructing databases of socio-political events and disasters in the world. Some of them use automatic systems, automatic event extraction systems. Some manual attack crisis rooms in some big organizations, in international organizations, in security organizations. During times of crisis, the people who are responsible for managing the crisis, they sit in front of big screens, obtain information and maps, including from the news, from event extraction systems, including from satellites, about the development of the situation, of the crisis situation inside the certain region. Usually this is during massive natural disasters. And there are also information systems which trigger alerts about military incidents, protests, riots, large-scale disaster humanitarian crisis. For example, our Europe Media Monitoring System is triggering alerts about important events and sends them through the email and SMS to journalists and people from the European Commission. So these applications require event extraction technology, which backs up them. And also it is important to follow the number of victims of armed conflicts in humanitarian crisis and other social political events. And this is again done with event extraction. So this is a small sample of event extraction extracted by the Joint Research Center Nexus system. So event type is armed conflicts, and the weapons are missiles and drone, and this is about the Philippine urges its Marines to avoid Red Sea and meet Houthi attacks. And since the news mentions the Houthi attacks, that the Houthis are attacking the ships with drones and missiles, then we have captured this as armed conflict, and the weapons is missile and drone. And then we also extract the snippet, and this is the snippet which you see on the screen. So this is another example. This is from the Russian-Ukrainian war, how basically the high precision strikes in Kursk, in Kharkiv. So this was some days ago, and when the news was published was 3 minutes ago, and the system recognizes automatically this airstrike, and it recognizes the weapon, which is a drone, and there is a snippet which is captured by the system. And there is another example. This is about shooting. The police officers killed. The reason is not, the motivation is not clear. And that is why the system says it is shooting generic type. And it also finds that the weapons are grenades and the guns and some other weapons. So this is all automatically extracted information, and it appears on our website, and it also enters into database of events automatically extracted. So this was about the Nexus system which we developed, and this is another project developed in United States. It's called Global Incident Event Map by the project Global Database of Events, Language and Tone. So the name of the project is Global Database of Events, Language and Tone, GDELT, so-called GDELT. It is a project, a very significant project. It monitors a huge amount of data, a huge amount of news in different languages, and extracts actors, places, time, and the manner. And basically, this project is one of the most interesting projects in event extraction. Automatically extracted events are filled into a database shown on the map, which you see here. So this is another way to visualize and present events to a map. And this one is another system which was developed inside our center. It is now being used in the Workfield organization by a new big project, which is called Epidemiology, Epidemic Intelligence from Open Sources, AIOS. So this is based in Switzerland, and they're monitoring after COVID. They started to monitor the the propagation of the various disease outbreaks, the development, and we managed to capture the place where outbreak and related to the outbreak events happen, and the number of victims. And so this is shown again on a map, and you can click on a point and see the details. So this is from the World Health Organization, this event detection system. I think you should see then in the slides. There are all the links, and you should test yourself. There are systems which you can directly use and see how they're working. So which are the stakeholders of the event extraction? These are researchers in political science. So they are researchers in political science which use the work of the researchers of natural language processing. So what you do in event extraction is likely to be used by other researchers in political science. So it's interdisciplinary domain. So you do research in one area, it's being used in another area. And there are these security people, policing, military, they're really crazy about this type of system. They want to monitor the news, and there are various systems in the world which monitor the news, and they pay big money to the NLP experts. So if you become good in the future, you're likely to work for the police and military, if you like. And then there are the decision makers in governments and international organizations. These are, let's say, more civilian people who are in power and use the output of our systems in order to monitor the development of conflicts and then decide if they can intervene in some area or not intervene. So this brings clarity and improves the decision-making process in the political and the international organizations. This is very important area of application of our technology, of the event extraction technology. So I have seen how the European Commission is using it, how the World Health Organization is using it. So this is something which stimulates me personally to work in this domain. Event extraction is really useful, and information extraction in general is useful for the decision making in political organizations. Now we're passing to the serious part, to the more technical part, and this is the data flow. So I'm going to sketch the various stages of event extraction, and then we'll go through each stage and we'll talk very briefly about the models and the resources which are being used. Very briefly, because there are many technologies underlying event extraction. So it starts with text stream, stream of news and stream of social media messages, which can be clusters of news, clusters of social media messages. And then we have pre-processing. The pre-processing is done through name entity recognition, through parsing, syntactic parsing, dictionary matching, and then this is passed to the next stage, which is about argument extraction. And here the arguments, so the participants in the events, the locations, the temporal expressions, they're being extracted inside this box, inside this stage. So victims, perpetrators, weapons, temporal expressions, and basically this is all information which is not related to each other. So we know there are killed people, there are injured people, but which is the event? Maybe there are different events, and one argument belongs to one event, and the other arguments belongs to another event. So one location belongs to one event, and one location to another. So this is the last stage. But before the last stage, we have the text classification and it discovers the events and makes event typization. So, for example, the systems may perform event detection on sentence level, and then they classify a sentence using text classification techniques, using various techniques. And then it may be done on a basis of text fragments. So some system analyze just the beginning of the news article, so they classify the news article. So some systems may even capture, do some sort of event aggregation, get the arguments, and then get the snippets which can around these arguments, and then make classification after them. Usually event aggregation is one of the last stages, so can be before or can be after or before the text classification, before event classification actually. Then the purpose of the event aggregation is to aggregating event templates, so creating, identifying the events out of the arguments and the classified sentences. So you imagine there are various entities, and then they're grouped into events, and this is the last stage, which is called event aggregation. So it aggregates event templates, finds if there are many events in one news article, and also it can link events to previous similar events, performing event co-reference or event causality. And now talking about preprocessing. Preprocessing is the most basic preprocessing is the image recognition. Without the image recognition, you cannot have event detection system. So you have this snippet, for example, that Gardini Donegal have seized 3,000 mapping products, contains suspected illegal cannabinoids, and during the course of the searches, they carried out in this city on 22nd of August. So what is important for every system which wants to analyze the news is the first step is to see which are the name entities, which are the organization, which is Gardai, is the Irish police, is called Gardai. The city Donegal, then there are two other cities, Bundoran and Donegal town. Then there are financial number, which is 3,000 euro, and it is also important, and the date, the 22nd August. Then we have the dictionary matching, which is also very important. The so-called event triggers, like in this case, Seizure, have ceased, usually are inside resources which are called domain-specific dictionaries. So these dictionaries are built in different ways. Could be automatically, semi-automatically by experts. So in these dictionaries, you have, for example, a phrase like "was killed." This is killing event, have seized, seizure event, kidnap, abduct, kidnapping event. Very roughly, this is how event dictionary looks like, event trigger dictionary looks like. So this dictionary items are matched inside the text using simple dictionary matching algorithms. Could be also regular expressions rather than fixed strings. And then it is important, but this is considered rather trivial to make sentence splittings. There are various tools for sentence splitting. And because usually events are reported in one, two, or three sentences, so it's important to capture the sentences. And then there is the argument extraction phase, which extracts the participants, extract the time, the affected infrastructure. So this example how from a text we arrive to the template. And so in this case, it is a news about Russian bombardment of the East Ukraine, and then we have event places, the identities of the dead people, how they are identified inside the text. So 6 people, 4 people, the perpetrators, and the effective infrastructure, which is a house. So this is the argument extraction, and this is before the other stages. It's an important stage in event extraction, argument extraction. There is a very important phase which is called event classification. So event classification is about having the text which describes the event, having the snippets which describe the event, and then we classify the text using text classification techniques, and we come out with event types. So we know that this event which is described in these sentences is of a specific type. For example, in this example, the word bombardment can trigger the event type air attack. And this can be done in different ways. Event classification can be based on sentences or bigger multi-sentence text fragments. And it is based, importantly, it's based on taxonomy, on a set of event types. And a very important taxonomy, for example, in the world of social political domain, is the Camel taxonomy. There are both machine learning based data driven methods for text classification and keyword based event classification techniques. So both are in use. And as I said, the last stage is the event aggregation. So from all this information, the event type and event arguments, we build the event template. So in this case, the event template about this news will be air attack. Event place is Donetsk, and that is 6 people. And then during the aggregation, we also parse the number of dead, the number of injured, the number of kidnapped. So there is parsing of the text and extraction of the numbers. So in this case, the number of dead is 6. And it is also important that the systems here should capture ideally 2 events. One event is of type air attack, which happened in Donetsk, and then another type is of unknown event types where Russians are perpetrators and the death of 4 people, and the infrastructure is a house. And the event place is another, is Malivka, is a village in Ukraine. On this stage, the system should group the arguments, the sentences, and should extract the event templates and should define the number of events. It is also important to know that it is not trivial to identify the different events inside one news article. One news article can report many events. So in this particular case, you can see the news which talk about 58 Palestinians who were killed in some Israeli attacks. So this is a concrete event, a concrete case of killing people in Gaza. But on the other hand, the whole event, the whole war in Gaza, which started in 7 October, is reported. Then the overall death toll is reported, and also the toll of the injured people is reported. So you have 2 events with 2 different sets of numbers and sets of arguments, and they're reported in the same news article. And so it is quite tricky. It requires some reasoning, and based on heuristics or text similarity, or there are no universal algorithms up to now how to really make difference between the events. That's not a trivial task, but that is required by event detection systems to make. In reality, what happens in reality is that these systems they basically capture just the main events on the basis of frequency. For example, these 58 Palestinians, 58 people, they repeated. So the system can say this is the main event where these 58 are mentioned, and so it looks around this number 58, and then it ignores the other parts of the text. So this is one heuristics which can be used. So this kind of heuristics, these rules are actually fundamental to build event extraction system. So we're going towards finishing, not towards finishing. This is the second part of the tutorial. Now, up to now, we managed to show what is the event template and what are the technology which underline the event detection, event extraction. So the event template, you have seen it, it contains time, location, victims, perpetrators, the numbers of the affected group of people, so how many people died, how many were injured, and also the template includes the weapons and the strategies used inside the social political event. And also it can include motivations, although it's more difficult to detect. And then we have seen that the main stages of the event extraction are name entity recognition, dictionary matching to detect, for example, event triggers in other maybe dictionary items, and argument extraction, so to detect the victims, the perpetrators, the time expressions, the occasions. And event classification is important. So to know what is the type of event, we need to classify the text. We need to say that this event is of type protest, this event is of type armed conflict, it is of type natural disaster, etc., etc. And then we have the event aggregation, which puts together the event templates. So as I said, the event templates are the event templates are not trivial to build because there may be many events in the same article, and there can be also different articles reporting about the same event. So these are the stages, the pre-processing steps, and the event template. So if you're going to build a system which performs event detections, have in mind that you always should detect time, location, event type. Time, location, event type. This is the most important. So if you want to have event detection system, it must detect when, where, and what the event type. So the three W are the most important. Otherwise, you don't have event detection system. It's something else. It is maybe used monitoring system, but it's not event detection. Events are time-oriented things, as Donald Davidson says, that time is important to location also. And we have shown two paradigms, we have mentioned two paradigms of event extraction. There are rule-based approaches, like grammars for parsing event descriptions, references to people, infrastructure, location, temporal expressions. All these are can be parsed by grammars. So the rule-based approaches they imply existence of grammars, domain-specific grammars, which find references to people, which find references to specific event phrases. Then, apart from the grammars, the rule-based approaches rely on dictionaries. So dictionaries of trigger expressions, dictionary like battle, protest, etc. Keywords or keyword combinations can be used in the rule-based approach to classify the events. So in the Europe Media Monitor and inside the Nexus event extraction system, we're using keyword combinations. So if you have the word protest and you have the word, for example, police or protesting or gathered or march, this is enough to say that the event is a protest or demonstration. Usually it's a combination of all four lists. So this and this word, and this word, etc. Now, these are the rule-based approaches, and these rule-based approaches still being used. They're being used in the research publication about them, but above all um, in the organizations which are using event detection, the rule-based approaches are still being used. Still, in the research world, on conferences, on the world of conferences and projects, scientific projects, the data-driven approach, machine learning approaches, they have largely taken over, and then all the papers on event detection is about using statistical models like BERT, supervector machines, and they use for classification, for classifying sentences into one event class or another. And then there are the sequence labeling techniques like conditional random fields, Markov models, and maximum entropy classifiers, which are being used to identify the name entities and to identify the arguments. So on the place of the grammars, the data-driven approach gives us the sequence labeling techniques. And these are conditional random fields and Markov models and maximum entropy models. This is the case that the data-driven approaches are more written about, but in reality, in practice, the rule-based approaches give, if not superior, they give competitive or the same performance as data-driven approaches. And for extracting arguments, I believe rule-based approaches are still the main in the field of event extraction. Simply sequence labeling techniques are not intelligent enough. They require more data, sequence labeling techniques. Rule-based approach is much more easy to build for detecting dimensions of people and name entities. So rule-based approaches are considered to be outlived by machine learning approaches, but they provide, that is not true, they provide the basis for applying human expertise, because they're created by linguists, those. Then transparency, so because you can see the rules, you can see how they work and why they do not work, that's transparency. So it's important that you know that something is not detected, and then you go and you see the rules and which detect this type of name entity, for example, or person entity, and then you see why it was not detected, that the rule misses something, and then you can correct this, and it's called transparency. And then it can introduce feedback in the rule, so you can see the output of the system, then you can correct the rule set, and then you can see another type of output. And then this is important because you can build a system which constantly improves. And with the data-driven approaches is like that you have a text corpus, and then you can play with the machine learning model, but you cannot make feedback, you cannot change the machine learning model, you can just retrain it. And that is it. So in reality, the both approaches are being used inside event detection. And both rule-based and data-driven and machine learning approaches are being used. The state of the art for text classification for classifying events are the BERT and the BERT-like models like Roberta or MuBERT, various BERT variations, fine-tuned on different text corpora, trained and fine-tuned on different text corpora. And the latest development is using the generative large language models to perform event detection. So this is a completely different step because basically you're using another model like a black box, the generative LLM is not really under our control. So this is an example of a rule-based detection of domain-specific noun phrase, and it is built with a formalism called Express. This Express formalism was developed in the Joint Research Center. And we're detecting here a person group which is based on nationality and based on a quantifier. So it will detect this group, things like many Italians, several Bulgarians, many American Buddhists, and group of religious Jews, for example. And the person group the rule is called person group, and it contains several elements: word, part-of-speech article, word, part-of-speech quantifier, and then three dictionary items which are taken from a dictionary. One is person modifier, and this person modifier will be like, for example, religious would be person modifier. So adjective which modify people. Then you can have proper noun singular, like for example, American, and then you can have the plural, which describes the noun, the name, which is the central for this noun phrase. For example, Buddhists or Bulgarians or Italians. So this rule, at the end of the day, exports a structure, which is a person group with a certain quantifier and a certain name. And they're taken from the words which are matched by the dictionaries, for example. And then this can be done on several levels. So, for example, another level, then after detecting the people, another level of the grammar is detecting the actions. So this level of the grammar takes the language structures from the previous level, so detected people, then combines them with dictionary output, for example, key phrases about killing or any other event type, and then says that if you have a person detected on the first stage, then you have a key phrase in a passive voice which is about killing, and then another person description. Then you have actor, perpetrator, which is the second, and the victim is the first. So this is done in this way. The argument extraction is done using grammars. So the grammars are used to perform argument extraction. And then we know that there is a mention of perpetrator and there is mention of death, and the grammar basically gives us the arguments of the event. So this is rule-based event argument detection. And it is based on, there is a serious literature on rule-based event extraction, and the first system which were built in the 1980s and the 1990s were exclusively based on rules, everything based on rules. They didn't use any machine learning, any text classification, which basically appeared on the stage in the 90s. But before that, there are wonderful systems like Hristo, which are still in the textbooks of information extraction, which are exclusively based on rules. And this literature is more recent. And for example, our center, we have published several works on rule-based event extraction and language domain-specific grammars. And we have also other works which are about rule-based event extraction. As a matter of fact, currently the rule-based event extraction is very largely used in bio-NLP. So in the biological bio event extraction, we do not talk about social events. We talk about events which are interaction between proteins and interaction between genes, but they're still events linguistically. So it's still event extraction. And rule-based is the preferred technique there. This is the schema of the generic schema of the machine learning based event extraction. So say most of the system classifies and they discover the events inside the sentence on a sentence by sentence basis. And so we have a sentence or a couple of sentences. And then the first step is name entity recognition. Then there is feature extraction. So feature extraction is name entity recognition, back-to-speech tagging as a second step, and the parsing. So many systems, especially in the world of research, which do not aim at efficiency, speed, and multilinguality, they use all these three stages: back-to-speech tagging, parsing, and name entity recognition. And these are considered features of the word features. And then these word features are being used to form vectors representing each word. And apart from this, the statistical systems are using word embeddings. They represent each word with a word embedding vector. And inside the word embedding vector, they also can insert additional elements like an name entity, or the back-to-speech, or the parsing, or the part of the parser from the root to the word. And all these features can be mixed in different level of a neural network architecture. So this is very generic, so I don't speak about very concrete technology. Here I say basically how a machine learning based technology for event extraction is working. So you can mix these features using various different layers of neural network. You can try to build yourself vectors and then put them in a text classification model, neural network, or SSVM. And then the final stage is to infer the arguments and to classify the sentence or the text fragment into event class. So these are the stages: feature extraction, representation of the text to numerical vectors, mixing the features and the vectors from the various stages, and then classification and inference of arguments and event type. So that's how the machine learning event extraction works in general. So this is very general architecture. So the first phase is the preprocessing and feature extraction, and so I'm going to say 2 words about how the data-driven approaches are doing name entity recognition, for example, and the feature extraction. The first step is name entity recognition, back-to-speech tagging, syntactic parsing. And the back-to-speech tagging and syntactic parsing, we have these libraries, and this would be useful for you if that's how you can look at the can have these slides. For example, the Stanford Core NLP is very largely used for parsing, multilingual parsing. And it works in English, French, German, Chinese, Spanish, Italian, Hungarian, and Arabic. This Stanford Core NLP. It is considered one of the best packages and works in Python. Then we have the Spacey. Space is also very largely used in the information extraction workflow. So Spacey does image recognition, speech tagging, and parsing, and it does this for 23 languages. And there is the Natural Language Toolkit. It's a Python library, NLTK. It's a very used library, more efficient, more fast, but less efficient than the Stanford Core NLP. And then there is Apache OpenNLP, which does image recognition, speech tagging, and also does parsing. So these four libraries important if you want to do information extraction or event extraction, and you don't want to do from scratch those things because they're very time consuming to develop. So there are ready-made tools already which you can use for developing your own information extraction system. So there is a toolbox, especially in Python. So if you know Python language, you have very easy way to install any of these libraries and then to build on the top of them something more intelligent. And that's actually very important. That if only this is part of you remember from this tutorial, I think that will be enough. So machine learning for preprocessing, there are those sequence labeling technologies like maximum entropy learning, conditional random field, and hidden Markov model, which is based on final state like representation. Basically, they represent the text like a graph with arcs showing probability of passing from one word to another. And they're built with different level of complexity, and they're used to label sequences of text. And there now the state of the art is combining this with the output of transformer-based architecture. So transformer-based architecture builds abstract representation, and the CRF and the hidden Markov models on the top of the transformer-based output, on the top of the contextual artworks embeddings, is discovering the sequences of so then there are the two technologies, the BERT and the BERT-like models, and the SVM and the text classification models. And they're using to classify text into classes, and there are also some recent work which proposes to integrate pattern matching closely into machine learning-based event extraction. So this is recent work which shows, for example, there is work how to present both the patterns, manually constructed patterns, and the text using transform architecture into word embedding sequences, and then match them. So this is integrating the pattern-based approach with machine learning approach. So again, about this sequence labeling, it is the state-of-the-art machine learning technique for name-entity recognition and for argument extraction. And as I said, there are transformer-based architectures. Combining this with transformer-based architectures, and then basically making this sequence labeling on the last field, on the last stage to discover the name entities, to discover the arguments. This is the state of the art of the document discovering technology, and there is this interesting paper surveying recent advances in sequence labeling from deep learning models. And then we pass to the classification. Classification and extraction of the arguments. For example, there is this work of Raul Grishman and Nguyen about detecting event triggers. Because, for example, if you have in the text just the word protest, that's not enough to say this is really a protest. This can be someone protests against something. So that's not a real protest. That's not event. So they built a multi-layer deep learning architecture which combines word embeddings, position embeddings, name entity embeddings, then mix them inside the deep learning architecture, deep learning neural network, and then as a final level, the deep learning architecture exports a vector, combined embedding vector, and then from this vector, the classifier is trained to say if word is actually event trigger or it's not event trigger. In this way, the system can learn if the sentence contain event or does not contain events. So this is an important technology. And again, about the sequence labeling for argument mining, usually the corpora, the corpora which are used, the text corpora which are used to train such kinds of sequence labeling approaches, they're annotated with the below schema, annotation schema, and which stands for beginning inside and last token outside and user length chunks. So, for example, these 5 people were killed will be annotated like this: 5 beginning people last, because here we annotate the dead people, the killed people, and it will be like that. Word by word, the words which are outside are O, and where the notation starts is B, and the last token is annotated with L. So basically, the algorithms get these sequences where they say where the entity begins, where the entity finishes. And then they train the methods rely on maximum entropy, hidden Markov model, conditional random fields to build then the feature vectors and to perform name entity recognition and argument binding. And the final stage is the classification, the event classification. So event extraction system processes text sentence by sentence, so by often they process the top 1, 2, or 3 sentences, and then there is feature engineering as part of the classification process. So all these name entities, embeddings, etc., they're used to build vectors, and then using these vectors, we pass them to a deep learning neural networks like BERT and Roberta, and then the text and the features are transformed. So basically, Roberta used to build from the features to build additional vectors, additional feature vectors, and then these feature vectors they used at the end to train deep neural network and derived to fine-tune BERT derived model or support vector machine to classify the text fragment and to derive the event type. So the event types are derived using text classification techniques and intensive feature engineering using BERT, using entity recognition, and as a result, we have a vector which is built out of these technologies, and then out of this feature vector, we are training a bigger we're training a text classifier. After we have built the vector of the embeddings and the name entities, so we have feature engineering we're using BERT usually and some large language models. That's the state of the art, and then we have text classification to derive the event types. So this is the event classification process, and then finally event template aggregation. So up to now, we sketched the most important part of event extraction, and the event template aggregation is the final stage. And probably this is one of the most important stages because it uses from the different parts, from argument in different areas, sentences classified into different event types. It should create one template or several templates. And this is an example how for example, about the complexity of this. So this is about, again, some Israeli strikes in the West Bank, and there are different numbers about the victims which the news reports. So this reports, this set of news, this cluster of news reports 4, 5, and 6 people dead. And we have used, the system is using, gives preference to the last reported numbers, which is 6, but it also considers the other numbers to see if the 6 is close to. So this is the final template which then the event detection system outputs. It says there is darknet conflict, there are 6 people dead and 2 people injured, which are children. This is the identities, to Israeli. And the snippet is this one. That's the snippet which contains most of the event. And there is also the place. So the event template aggregation finishes with this kind of descriptions, and then this kind of descriptions can be shown on the information system, and then can go into a database because that's structured representation of the news. So this is the final product of the event detection, the event extraction technology. You have a template which is semantically explains the events and what happened and for the participants. So it is, in a way, semantic description of the event. And there are many problems in product event template aggregation. I will just mention them in this tutorial and just schedule solutions. And the problem number one. One news article may mention different events, and for example, one article may talk about both the war of Russia and Ukraine. It can mention two battles inside this war, and it can also mention the whole statistics about the whole war. So there are 3 events: the whole war and the 2 battles. Then actually problem number 1 is that in one news article, event is mentioned in different parts of the article. So this is a very tough problem because apart from the fact one article can contain many events, then one event can be put into different sentences and then in different places, not in sequence sentences. And this is the problem. And then the same events can be mentioned in different news articles, social media messages. So we have here the problem of duplication and information overflow. So if you want to monitor the news and you have 1,000 news detected or 1,000 Twitter messages detected which mention the same event, that's not really, does not save you much work. And this is one problem, that there are a lot of news sources which report the same event. So there are some solutions. So one solution is clustering. So we can cluster the articles and social media messages by their textual content, and there are different methods for clustering. There are many different methods, and the most recent one is they're based on LSA. LSA is used a lot in clustering. Then there are also textual embeddings are used, word embeddings are used as representing the text before clustering. Then one can decide to process only the leading sentences in the title in order to detect the most important event, which in the news article is clearly mentioned in the beginning. So the journalists usually mention in the top 3 sentences and in the title the most important events, and that's the choice of our event detection system. The Nexus is processing just the beginning of the articles in order to capture just one most important event. And then the other solution, another part of the solution is to take the most frequently mentioned locations, actors, victim descriptions, victim numbers, and ignoring the others. So, for example, if across the articles you have the word 58 mentioned 3 times, that's probably more important. So you take these arguments which mention the number 58. And I have basically left this part as a final one. Event classification taxonomy is an example of extracted events because event classification taxonomy are a field on which on which are working linguists and experts in ontology, and even people from political science. They're working on creating classification taxonomy. So these classification taxonomies are not specific for the NLP, but they're more interdisciplinary resource. And this resource is being currently it is being created also by the scientists in political science. And without doubt, in the world of event extraction, the most outstanding taxonomy is the Conflict and Mediation Event Observatory, or called CAMEO. CAMEO was started in the 2000 in the University of Kansas with the financial support of National Science Foundation of USA. And then there, okay, I wrote two well-known social political event data sets. In reality, there are more. So the most important are integrated conflicts early warning system, ECEWS, which is financed and maintained by the DARPA and is currently used by the United States military, this database of events, which used to be automatically fed by events. And there is the global event language and tone data set, the GDELT, which I have shown on this map, and I'll talk after a while, show more about it. The GDELT is a very interesting project with hundreds of thousands of events, and if you want to train event detection, information extraction, or sentiment analysis system, the GDELT project is, because it's a public project with downloadable data. You can download as much as you want, geolocate in specific country. The only thing is it's automatically detected, so accuracy you should see yourself how it is, but it is a very well-known project. And there was the Phoenix database from the Pennsylvania State University, and this Phoenix database, I'm not sure if it is downloadable. I think it is downloadable. And the ICEWS is also downloadable, but the previous events, not the current ones, because this maintained by the military, and they just make public available, I think, only part of it. And this is about the databases which use the Camel taxonomy, and there are many other projects which use the Camel taxonomy. So this Camel taxonomy is very fundamental for the event extraction. And the event taxonomy objective of Camel is the called integrated data events analysis IDEA, and it was developed inside a project called Panda. So it's considered parallel to Camel, but in reality there are few databases, maybe only one which uses the IDEA. Still, it is more detailed, I believe, taxonomy, but Camel is more widely used. And in the European Commission Joint Research Center, we have developed the Nexus event, our own taxonomy. And this taxonomy is, you can just use it as an inspiration. We just use it in our system. And we have our own corpus, actually, which uses this taxonomy. So this is not important taxonomy, but we have a corpus built on the basis of it. So the Camel taxonomy, Camel code book, that's something which you should see, because if you're doing social political event extraction, they're the most important event types. Like professors in sociology have sit together and they have created a list of the important events which are mentioned in the news, and they classify them into three-level taxonomy. And this is important resource for everyone who is who's working in the event extraction field. And these are the high-level types to which they came, and you can see that 20 event types, and that just the top of the taxonomy. So my public statement, appeal, expressing taste to cooperate, consult, engage in cooperation, engage material cooperation, provide aid, yield, investigate, demand, disapprove, reject, threaten, protest, exhibit military posture, reduce relations, coerce, assault, fight. These are all the military security types are in this coerce, assault, fight, and then engage in unconditional mass violence. So these are the top types. So I say this is something to which political and social scientists came to when they analyzed big amounts of news, and This is created in the Kansas University and then used in various databases. That makes this classification important. The databases of events which use this taxonomy. And I wanted even to go further to show some event types and subtypes to give you an idea how it looks like. So, for example, this the fine-grained event types of engaged diplomatic cooperation. So, number 5 is engaged, and number 57, 57, is a signed formal agreement. So, for example, this is a very old news for about the Czechoslovakia and China signed agreement that's in the 1980, and they're changing. So
Maybe 5 more minutes.
it won't. I can finish. No, not just up there. I can finish. Okay, so pass fast to this basically. Yeah, other great event types, physical sound, etc. Types, okay, territory. Then there is our taxonomy, this nexus taxonomy, and you see basically you have divided the world of the events into social, political, crime, legal, targeted violence, and disasters, and also violence without specific motivation. So these are our event types. Social, political are military, unrest, humanitarian, and terrorism. These are the typical social, political events. I just give the example of the nexus output you have already seen. For example, this humanitarian crisis, it detects the number of the various numbers of affected people. This is another about deportation detected by nexus. This is another one about humanitarian crisis. These are two. Nexus can work in 7 languages, and so this is example in Arabic. This is in Spanish. And then just very fast about the resources. So this is the part maybe which you would like to see after the slides are published. Direct event databases provides an event database which is manually created, and it contains the recent armed conflicts and cases of unrest and other political events. And what is when you go to this site accreditdata.com, you should go to the park data, and then you should ask via email about the credentials, and then you can download millions of records of events with text and field about location and time and the actors. And then there is the GDL project.org, which I mentioned. This is automatically created database of events in 100 languages, automatically translated from every country in the world. A very ambitious project. And important fields in their data. There are much more, many more, but there is event class, date, 3 locations, the location of the 2 actors and the action, 2 main actors description, and event impact using the Goldstein index, and many other fields actually. And then we have our own EMM event corpus. So this is the link to the EMM event corpus, and this I provide just for you because it's still not official. So you can steal it until it is public, and they didn't notice it. That's a very nice corpus. It's a highly tens of thousands of events, actually about 500,000 of events in English, 10 years of data in English language. So you should use this link until it's active. And this example from the corpus event type, it's manually curated part of it. So the risk tag, date, URL of the article, the place with the coordinates, the passenger number. And then there is the events document corpus, which is available from GitHub, and it's created by Pierre Vossen and Tommaso Caselli. And there is this paper, the event storyline corpus, where you have events which are connected with causal relations. So that's a very interesting resource also. And of course, our case workshop. This is the workshop where we also provide corpus for the participants in the chat task, and for the very interested researchers also believe. We have Twitter channel, website, and also provide a corpus if you participate, especially in the shared tasks. And that's it. Thank you.